regression. So see, if we recall the regression class, this was the model, or this was for what? Linear regression. Am I right? Yeah. So what is the things here is that in case of a regression, this y is a real value. Yes or no?
Yes, sir.
And so this y is a real value. That means it can have value less than 0 or it can have value greater than 0. That means y predicted can be greater than 1 or it can be less than 0. Can be any value. So what is the case when we are going to predict the class instead of the label, instead of the real value? Class means, suppose I gave you an example, you are having some data, see, and in that data you need to just check whether you are having some images of persons. They may be the female or they may be the male. So the thing is that you need to classify them as a male data or female data. How many are them female, how many are them male, and suppose you are giving some input image and then you need to predict this one is the male image or this one is the female image. So this time we are not going to predict the real value, we are just going to predict the class. Okay. So now we are interested in asking the question, what is the probability that the example, that means the data point, belong to a particular class, belong to a particular class. Fine. Is it clear? This time we are going to predict whether a particular example belongs to which class. See, is it clear? Hello?
Yes, sir. Yes, sir.
Okay, I can give you the same data set. If you remember the house data. Now this time you are having their square feet area, and this time you are having suppose two class. The square feet area maybe thousands, maybe 2000 suppose, and suppose this is a class 1, that means this is a middle income, and this is an upper income. Okay, so this time we are not going to predict the price of the house, we are going to predict which house is in the middle income group or which house is in the upper income group house. So we are just categorizing them in, or we are just predicting their class instead of predicting the real value, their price. Okay. One more example is that suppose we are having some images. Okay. Male images, female images. Suppose this is male image, this is female image, this is male image, this is female image. Okay. So we are having this kind of data. We will build our model, and using this model we are having some image and we need to predict male or female. So this type of problem comes under the category of classification. Clear? Now see, if we talk about the regression that we discussed, so in the regression, in case of a linear regression, we are going to predict this mx plus c. This is a real value. This is a real value. Now what we can do in this is, suppose if we just set some threshold 0.5, And if we say if this threshold value is greater than 0.5 or greater than equals to 0.5, then we can say, okay, this is in the class 1, else it is in class 2. It is just an example I'm telling you. Suppose in the housing price data, so we are having we are having the price of the house. Instead of the price, we are having their class, whether it is a middle income or upper income group house. So what we can do, we can predict their real values using MX plus C, and we can instead of a real value, we can find the probability. Okay, and we can set some threshold value. Okay, or we can set some threshold value, and then we will see if this value is greater than this threshold, then it will be in the class 1, otherwise it will be in the class 2. Is it clear? Hello?
Yes, sir.
Okay. If you remember in the class, I have given you one question based in classification ka, where we were having the data related to the cancer data, and we have predicted the probability, conditional probability, if you remember. So we have calculated this P of A slash B, and I set the threshold 0.9. 0.9. So if this probability is greater than 0.9, then I said, okay, this is a cancer, else it is a not cancer. If you remember from the lab, uh, in the first lab, we discussed about the Bayes theorem, BAYES, Bayes theorem. If you remember, okay? In the Bayes theorem, I gave you an numerical. In that numerical, you were going to calculate this conditional probability. Okay, and I in the question I just added one more thing. If this probability is greater than 0.9, then there may be there is the case of the cancerous patient, otherwise it is not cancerous. Do you remember this, or I can show you? Just let me see here. I will show you once again. See, not cancer, about this spam. See here, assuming that the spam detector is spamly detected. See, if the probability of the email to be spam is greater than 0.9, then classify it as a spam. Otherwise, classify it as a not spam. Do you remember this question from the lab?
Yes, sir.
Okay.
Yes, sir.
So we were using Bayesian theorem. Using the Bayesian theorem, we have calculated their probability. Okay. And we have this in the question, it is given that if this is greater than 0.9, then classify this as an spam. Okay. So originally in the numerical, we just find the probability, that is the numerical data. But based on some threshold, we just classify it as a spam or not a spam. ठीक है, so I'm just giving you the example, not मतलब Bayesian theorem, cancer not cancer. ठीक है, so in machine learning, classification refer to the predictive modeling problem where a class level is to be predicted. ठीक, so if someone asks you what is the difference between the regression and classification, what will be the answer? What is the difference between regression and classification? Hello.
Sir, in classification,
Classification दो में होती है.
Yes, in case of regression, we are going to predict the real value. Okay. For an example, suppose we are going to predict the price of the house. So the price of the house can be the real value. Okay. In case of a classification, instead of predicting the real value, we are going to predict their class. In the same example for the housing pricing data, instead of predicting the price of the house, we can predict their level, whether it is a middle income group house or whether it is an upper group house, or whether you are having some data set related to the x-ray of some chest x-ray. Okay, and you are going to predict whether there is a chance of lung infection or not, or whether there is a cancerous image or not cancerous image, whether it is a female image or whether it is a male image, or जैसे कि whether it is a spam or whether it is a not spam. So classification just the categorizing, मतलब just predict in which category it belongs to. ठीक है, and in case of regression we are going to predict the real value. Clear? Is it fine?
Yes, sir.
Okay. So some examples of classification we can have spam, not spam. One more classification we will discuss in the lab, handwritten characters classification. Or more specifically, we have some data set, handwritten digits like 1, 2, 3, 4, 5, 6, 7, 8, 9, and this data set is large, not in this manner. Sometimes we have too many ones with too many zeros and so on, and we need to just classify a particular handwritten digit, whether it is a 1, whether it is a 2, whether it is a 3, or whether it is a 4 or 5. Okay, so in case of classification, how many classes we can have? It depends on the question. In case of email classification, how many classes are there?
2.
There are two classes, two class. Yeah. Whether it is a spam or not spam. In case of handwritten characters, it depends how many characters. So suppose I am giving handwritten digits, hand written digits, 1 to 9, or you can say 0 to 9, 0 to 9. So how many? 10 class. Yes or no? Whether it is a 0 or whether it is a 1 or whether it is a 2 or whether it is a 3 or 4 or 5 and so on. So when the class, we will discuss in detail about this. So the examples are not limited. I have given just two example, email classification and the handwritten characters, but the examples are not limited. So till now it is clear what is classification, some examples of classification.
Yes, sir.
Yeah, no doubt now. Okay? Now see one more thing. Okay? Now just consider the email classification. What kind of data you have? It is a numeric data or it is a text? It is a numeric data. It is a text.
Yes, sir.
Yeah. So there is a terminology used in case of classification. When you read some book, you will find this thing, label encoding. So I'm just giving you a brief idea. So in case of a learning, our variables are required to be in numeric. This should be numeric. But but in our case, like email classification, the data may be some categorical data you may have. Okay. Like जैसे कि we talk about the labels of our email classification. So the labels are two, whether it is a mail or sorry, whether it is a spam or whether it is a not spam. Okay. So this means if your data contain categorical data, we must encode them. We must encode it to numbers before we can fit our model. Okay. So in the lab, I will discuss the email classification problem where I will show you how this categorical data will be converted into the numeric data. Okay. So we must use some kind of encoding. Clear? What is label encoding is here?
Yes, sir.
है ना? So this is the same
नहीं
example
सर,
I
एक बार
have.
फिर से समझा दो।
See, in case of in the learning, in the learning, be required our input and output variable to be numeric. जैसे कि if we remember the house data, ठीक है? So we were having the price here, we were having the square feet area, or we have a number of rooms, ठीक है? This data is numeric. Number of rooms 3, price is 20 lakh, ठीक है? Square feet area 2000, number of room 6, price is 45 lakh, ठीक है? So this data is numeric, ठीक है? So in case of learning, our input and output variable to be numeric, ठीक है? These are output, the price is the output data and this is the input data, square feet area and the number of rooms. But if we have some categorical data, just like suppose we are having a message here, we are having its class message. Suppose you are having a 10% discount, so it is a spam. And there is a one more message, hi students, it is a not spam. So this data is not in the numeric form. So this data you can say it is the output is the category and input are some text. Okay. So in that case, we need to transform our data. Okay. Or the terminology used here, we need to encode our data to the numbers or numeric before processing them. So this is called label encoding. This is called.
ओके सर, अब समझ आया।
ठीक है, ठीक है. So I'm just talking about the labels, not the whole data. It is written here labels only. ठीक है. So suppose in case of email classification, what are our labels? Our labels are the spam or not spam. ठीक है. Labels है हमारे, labels हैं spam and not spam. These are two labels. Okay. So in that case, we need to transform them into numeric. So what we can do, we can use for not spam, we can say this is 0, or for spam, we can say this is 1. Okay. So class labels are often strings. In this example, class labels, these are the strings like spam or not spam. And we must map to numeric values before being provided to an algorithm. Okay. So one example I have given you, we can set spam as a 0 or spam as a 1, not spam as a 0. It depends on कैसे आपको करना है 0. ठीक है. So this is just an example of label encoding. This is clear? Hello.
Yes. Yes, sir.
ठीक है.
यस
Yeah, it is just an example. I'm not discussing about the label encoding algorithms. There are the two type of label encoding algorithms are there, but these are not in the detail in your syllabus. एक होता है hot encoding, 1-to-1. There are different things. So I'm just giving you the brief idea कि what is label encoding. If you encounter some, whenever you read some books or some internet resources, so you will see this time of terminology. Okay. So this is called label encoding. This will be used in case of classification. Okay. We will discuss the same thing in the example with the Python code itself. Okay. Now see, sometimes what happen, sometimes instead of class label, our task is to predict the probability. Probability is always in the between 0 to 1. Am I right? So probability is always 0 to 1. Okay. So suppose you are having probability is equals to 0.8. ठीक है. Now what happened? Some task may require prediction of the probability of class member. So suppose I am talking about the cancer data. Cancer data. So you are not going to predict the level whether it is a cancer, not cancer. You are just going to predict the probability of cancer and the probability of not cancer. And then the person will decide if this is the probability, then this may be the case of the cancer, and if this is the probability, then this may be the case of cancer. So just like the doctor analyze the images. Okay. In the medical field, the doctors have some tools where they give the input X-ray images or in mammograms in case of breast cancers, and they just see the probability, and using their knowledge, their experience, they predict if this probability is greater than this, then this may be the case of cancerous patient. Okay, so sometimes instead of class level, we need just to predict the probability of the class. Okay, so if there are two classes, maybe cancer class, maybe cancer not cancer, so instead of predicting actual class, we are going to predict the probability of that class. Is it fine?
Yes, sir.
So now we are talking about the specific classification. Okay, so binary classification. Binary means two class. Binary means two class. So in this one class is called the normal and another class is called the abnormal. Okay, like spam. So not spam is the normal and the spam is the abnormal. So two case binary classification is, or you can say it also called two class classification. It also called two class classification, in which one class is the normal state and another class is called the abnormal state. In general, we say normal or normal, we just give them 0 1. Okay. So general convention, this is just a general convention. Okay. The class for the normal state is assigned to level 0 and the class with the abnormal state is just assigned to 1. This one, it is just a general convention. So if we are talking about the email classification, whether it is spam or not spam, so abnormal it is in spam, so spam we can say it is a 1, or for case of not spam we can say it is a class 0. Okay. One more example, cancer is not detected, it is a normal state, and if cancer is detected, it is an abnormal state. So we can say this 0, cancer not detected, and the cancer detected is 1. So you can say it is a 0 1 classification, or you can say the binary classification or two class classification. So it is a specific type of classification where the number of labels are 2, where the number of labels are 2. Clear? This example is clear? This classification?
Yes, sir.
Yes. Now, if you remember the previous lecture, I give you some example of regression, and one of them was logistic regression. So regression we already learned. We already learned this regression. Okay. In case of regression, we are going to fit a model f of x. Okay. By cap is equals to f of x. For linear, y equals to mx plus c. Okay. Where y can have a real value. Now see, I'm just giving you one modification here. 1 upon 1 plus e to the power minus f of x. Okay. 1 upon 1 plus e to the power minus f of x. Now, can anyone tell me what will be the possible range of this value 1 upon 1 plus e to the power fx? Anyone? Fx can have any real value. Fx can have any real value. That means it can have a minus 100. It can have minus 1000. Clear? Now, so anyone can tell me 1 upon 1 plus e to the power minus f of x? Hello? Hello? Can you hear me?
Yes, sir. Yes, sir.
Yeah, so what will be the possible values of 1 upon 1 plus e to the power minus f of x? Suppose f of x is equals to 100. We are talking about the housing price data. Okay? So suppose f of x is equals to 10 lakh. Suppose 10. Okay. What will be the 1 upon 1 plus f e to the power minus f of x? It
Sir, it
must
should be
be,
less than 1. It should be less than 1, like in 0
yes,
point something.
yes, it will be from 0 to 1. It will be from 0 to 1. Yes or no? It will be from 0 to 1. Okay. Now
Yes, sir.
suppose, yeah, I'm just writing here something. F of x is equals to 1, 2, 3, and 1 upon 1 plus e to the power minus f of x. Okay. So f of x is equals to 1. Then it is a 1 upon 1 plus e to the power minus 1. So how much it will be? Matlab, it is increasing or decreasing when f is increasing?
Sir, it would decrease.
Sure.
Sir, when the value of x is decreasing, the value of expression would decrease, right?
If f of x is increasing, okay, e upon 1 plus e. Okay. Now f of x is equals to 2, so e की power 2 upon 1 plus e की power 2, e की power 3 upon 1 plus e की power 3. Now anyone can predict? Hello? Hello?
Yes, sir, you're audible.
Yeah. So what I'm saying that it is always 0 to 1. It is always 0 to 1, and it will follow some pattern. Okay. So you can see we have transformed our real value into 0 to 1. Into 0 to 1. Yes or no? We have transformed our f of x and from real value to 0 to 1. Now here what we can do, we can set some threshold. Some threshold 0.5, and if 1 upon 1 plus e to the power minus f of x is greater than equals to 0.5, okay, it is a class 1. Else class 0. We can do this or not? So it is just an example here where I'm using a regression. Now the regression we have transformed from the linear regression to the logistic one. So where the real value are converted from real values are converted in 0 to 1. Yes or no?
Yes, sir.
So it is just an example. Okay, so this is a logistic regression, you can say. Okay, or this is the function here. But we also have different kinds of function where instead of e to the power minus f of x, we have some 10 cos like this. Okay. So some algorithms, what are the some popular algorithms? One of them is the logistic regression. Another one is the support vector machine, then naive Bayes classifier. The naive Bayes classifier just like the Gauss naive Bayes. Okay. And the k nearest neighbor. Okay. So I can show you this support vector machine in a research paper as well. Just give me 1 minute. I will show you this also used in the research paper. Just a minute. I'm showing you. In the research paper as well, it is used. Expert system में this paper is this. ठीक है, see, okay, it is opening, just a minute. So it is used in the mammogram classification, where we have mammograms means the breast cancer images. Okay, the cancer that is generally found in the women's, so breast cancer images, and using the support vector machine learning algorithm, we build our model, and using that model we are going to predict whether the mammogram is cancerous or not cancerous. So it is just loading, it is taking few minutes. Okay. Okay. Just a minute, it is loading. Slow net. Yeah, this is the paper here. So here you can see, I will show you SVM, control F, SVM. Yeah, you can see SVM. It is visible?
Yes, sir.
Support vector machine. Full form is the support vector machine. Okay, so we will also discuss this support vector machine in our lab. Okay, so this is the support vector machine, and which is used for mammogram classification. Mammogram means the breast cancer X-ray images. Breast cancer X-ray images. Classify them whether it is a cancerous or not cancerous, and using which class, which algorithm? Support vector machine. The support vector machine that I have written here. Support vector machine, SVM. Okay. So these are the some popular algorithms, but these are not limited. There are a lot of algorithms are there for classification. Okay. So I have written few of them. Logistic, these are the most widely used. Logistic regression, it is just the modification of the regression. What is the modification? You can see in the regression we have this function y equals to fx of for linear y equals to mx plus c, and we have transformed this linear regression, regression as an logistic 1 upon 1 plus e to the power minus f of x. So where the real values are transformed to 0 to 1. Okay. Now we can set some threshold. We can set 0.5 as a threshold. If this value is greater than 0.5, then it will be the class 1, otherwise it will be the class 0. Another example is the support vector, another algorithm is the support vector machine. Okay, naive Bayes classifier and k nearest neighbor. Okay, so these are the some popular algorithms. So this is clear. Can we move further?
Yes, sir.
Okay. Now the multi-class. The name itself tells the definition. Multi-class means we have more than two class labels. More than two class labels. Now the face classification example is the face classification. So suppose you are having a bunch of images. A bunch of images. There may be the image of a Prime Minister of India. There may be the image of Chief Minister of Uttar Pradesh. There may be the image of Chief Minister of Madhya Pradesh. So maybe you have 100 images of Prime Minister, 200 images of Chief Minister, or different numbers of images for different people. So suppose there are 10 pupils are there. Okay. So your goal is to build your model that will predict, if you give some input image, then it will predict whether it is a prime minister image or whether it is a chief minister image and any other task. Okay. So one example is the face classification, and the number of class will depend how many levels are you have. Okay. Plant species classification. So you are having some data related to the plant species, and using this data you are going to build your model. The model goal is to predict the species of a particular plant. Clear? And handwritten digits classification, the example that I have given to you. Handwritten digit classification we will do in the lab. Okay, so these examples are clear. In the handwritten digits classification, we have some data where we have handwritten digits from 0 to 9. Handwritten digits from 0 to 9, and our goal is to build the model that will predict whether it is a 0 or whether it is a 1 or whether it is a 2 or whether it is a 3 and so on. Clear? This is clear. What is multi-class classification?
Yes, sir.
Okay. So generally we have to if there are 3 class, then it also comes under the category of multi-class. 4 class then also comes under the category of multi-class. Okay. So no one asked me one thing, whether there is a case of one class classification. It can or it cannot.
Sir, one class मतलब?
हमने जैसे we discussed 2 class classification or binary, and I discussed multi-class classification, but I didn't discuss before binary or before multi. I didn't tell you one class classification.
सर वन क्लास पॉसिबल नहीं है, लाइक अगर वो क्लासिफिकेशन होगी तो अगर यस नो भी है नॉर्मल तो एक नॉट भी होएगा ना, जैसे
Okay, I
स्पैम
will
है
give
और
you.
स्पैम नहीं है उसमें तो होगा.
Okay. I will give you an example. I will give you an example. Okay. An example I can give you. Suppose you are having some data and you just need to find the abnormalities in that data. Abnormalities. So you are not going to categorize this data, or you are not going to classify this data into 2 category or 3 category. You are having some data and you are just going to predict whether there is some kind of abnormality in this data or not. Okay, just a minute. Give me 1 minute. Okay. See here. See, anomaly detection or nobility detection. So you are having data, okay, and you are trying to identify objects of a specific class among all the objects. Okay. So you are not going to classify whether it is a whether it is a 2 class, 3 class. Your goal is to just identify a particular class only, just like anomaly detection. Anomaly detection means you have something. We do not know what is. Okay. You have some kind of data, maybe related to some maybe some machine related data. Okay. And our goal is to detect whether there is an anomaly in this machine data or not. One more example, suppose you are having some objects and you just need to predict whether this is a noble or not. novel or not. Okay, or outlier detection, it is generally used in image processing. Okay, so it is just, you can say, one more terminology used for one classification is called imbalanced data. Imbalanced data, what does it means? If we talk about thousands of images, in thousands of images, suppose you are having some images which are not good or which doesn't fit in that data, so this you can say imbalanced data. Or suppose if we talk about images of male and female, and suppose you are having thousands male images and maybe 10 images for female, so these are, you can say, the anomaly. These 10 female images are anomaly, you can say. These are not should be in this data. They comes by error. Okay, so this terminology I'm telling you because when you read some paper, then you will encounter this thing. Okay, anomaly detection. What is anomaly detection? What is outlier detection? So you thought that in the class doesn't discuss. That's why I'm giving you the idea. ठीक है, कभी कभी in internet or whenever you read some book, you will find this terminology as well. Imbalanced data set or anomaly detection, outlier detection, nullity detection, or one class. Okay, so these are all correlated. So I'm coming to my discussion. कहाँ पे थे हम? मल्टी क्लास. ठीक, I will discuss that part. ठीक है, no problem. So multi-class classification is clear. Multi-class classification is clear.
Yes, sir.
ठीक है, examples
Yes,
are
sir.
clear. Example जैसे handwritten digits we can have some face recognition data. ठीक है, or we can have plant species data. So these are all the multi-class classification. ठीक है, now some popular algorithm for multi-class classification are the gradient boosting, naive Bayes, and k nearest neighbor. ठीक है, now the question is that how we will model multi-class classification problem. This is the question here. So I'm giving you a brief idea. See here. Suppose yeah, this is an example. Suppose you are having a data uh, which have 4 color balls: red, green, blue, and yellow. Okay. And what I'm going to do, we are um, uh, we are going to build a multi-class classification model. So how it works? Because we discussed binary classification. Okay. So we are familiar with the binary classification. What in the binary classification, we will find the probability. Okay. If and we will set some threshold. And if the probability is greater than this threshold, then this is in the first class. If the probability is less than that threshold, then it is in the second class. Okay. But what we will do when we will have more than 2 class? What we will do when we will have more than 2 class? So for this, the algorithms that are designed for binary classification can be adapted for use for multi-class problem. Okay. So the algorithms that are used for binary classification can be adapted. It is written here, can be adapted for multi-class. कैसे? How? Are you getting my question? What is my points here?
Yes, sir.
है ना? See, we discussed binary classification. ठीक है? In case of binary classification, we will find some probability. ठीक है? We will set some threshold, and based on threshold, we will decide whether it is a class 1 or class 2. But in case of we have more than 2 class, suppose we have 3 class or 4 class, then how it will work? Just think about mathematically how it will work. theoretically it is clear. We have 3 classes, 4 classes, so we are going to build our model that will do that classification. But how mathematically it will work? Okay. So for that, see, we know binary classification. So what we can do, we can use binary classification that is adapted for multi-class. कैसे? See, there is a terminology that is called one versus rest. One versus. These are all in your books, okay? But I'm just giving you in a simple. I'm trying to explain the simple language. One versus rest. So suppose you are having 4 class: red, green, blue, yellow. Okay. So now what we will do, we will use binary classification. We will use binary classification, and we will assume that we have only 2 class. We have only 2 class. First one is the red and second one is the others. Okay. Then we will do one more classification. So we will use second class, that is green, and then others. So we have only 2 class here. Either it is red color or it is any other color. Whether it is a green color or any other color. Whether it is a blue color or any other color. Whether it is a yellow color or any other color. Okay. So suppose we are having 4 class. So we will use 4 binary classification. We will use 4 binary classification. One versus rest. One versus rest. So we will take first class. Okay, and then rest of the classes. Okay, then we will take the second class, then rest of the classes. Then we will take third class, then rest of the classes. So so in that case, we need to use n number times binary classification. N number times binary classification. And I think it is clear, my point.
Yes.
You know, so one versus rest means one class versus all other classes. Okay, so 2 class will be there. One class, okay, and other class. Then second class and the remaining class. Third class and then the remaining class. Fourth class, then the remaining class. So if we have 10 classes, suppose in the handwritten digits classification, so 10 binary classification we need to do. ठीक है, बट क्या होगा कि पाइथन लाइब्रेरीज आर बिल्ड सो दे इंटरनली हैव दिस काइंड ऑफ मैकेनिज्म. ठीक है, सो we don't need to take care, but we should know मतलब how it works. ठीक है, if someone asks you in the interview कि how multi-class classification work, be already familiar with the mathematics of binary classification. So this is the case, either this is the one versus rest or one more is there. One more is there, one versus one. ठीक है, वन वर्सेस वन में क्या होगा, वी विल यूज सपोज वी हैव 4 क्लासेस, ब्लू, रेड, ग्रीन, येलो. सो वी विल क्या करेंगे, ब्लू वर्सेस रेड, फिर ब्लू वर्सेस ग्रीन, ये दोनों 2 क्लास है ना, फिर ब्लू वर्सेस येलो. ठीक है, सो ब्लू विथ ऑल ऑफ देम clear. Now we will do red versus green, then red versus yellow. ठीक है, then we will do green versus yellow. Green versus yellow. ठीक है, so it is called one versus one. ठीक है, how many classes are, how many binary classification we need to do? n minus 1 upon 2. Am I right? If we are having n number of classes, then how many binary classification we need to do? One versus one में? Please answer.
Sir, can you repeat your question?
See, we are doing one versus one binary classification. ठीक है, so suppose we are having 4 class, 4 class means red, blue, red, green, yellow, 4 class. And we are following 1 versus 1 binary classification. 1 versus 1 binary classification. That means we will consider first problem in which we have 2 class, blue and red. We will consider second problem where we have 2 class, blue and green. Okay, then we will consider third problem where we will have blue and yellow. Okay, ये clear. Then we will consider next problem, we will have red versus green. Then we will have next problem, then we will have consider red and yellow, and so on. So my question is, if we are following 1 versus 1, then how many binary classification we need?
So n minus 1 divided by 2.
Yes, n minus 1 divided by 2. So in the previous one, we were having the n number of binary classification, but this time we are having n minus 1 divided by 2. Okay, so that I was going to this. So this is for today, and then we will continue this maybe 20 half lecture will it will take. Clear? So till now, any question? Anything you want to ask?